Welcome to Math 20-3, 3.1 Surface Area of Prisms, also corresponding to page 126 in the workbook. In example 1, we've got questioning the area of each figure. Alright, if you recall above on the handouts above, the area of this shape is a rectangle, and the formulaic way to solve the area is length times width. So what we're going to do first is we're going to look at the numbers, length being 6.8 and the width being 4.5. We would use a calculator if you needed to do that. I'm going to pull one over here right now. Ta-da! I'll just move it over to space, turn it on. Alright, so 6.8 times 4.5. And so the answer would be 30.6 in terms of its numerical value. 30.6. Now, let's pull this off the screen for a second. Now we look at the units here because we are also taking the units of centimeters and centimeters. So we're taking centimeters times centimeters, providing us the proper unit for centimeters square. Alright, so now we have a triangle. Making sure it's on the pen. Nope, it's not in color. Blue, okay. Alright, we have ourselves a triangle. Again, the formula for above on your handout, your workbook, area is equal to, this time, base times height. So I'll put a letter by side letter, and then divide by 2. The base, in this case, is 12.8. Whoops. Oh, it changed my pen. Whoops. 12.8. Going to multiply that by 7.8, and then I will divide those by 2. So, because of the decimal format, and you want to, how do you do it in a calculator? Pull it across. 12.8 times 7.8, and we're going to get 99.84 equals 99.84. And if we need to round, we can round, but we'll just leave it there with all the precision provided for us. And again, because we actually have centimeters, let me pull this off yet again, and we have centimeters again. Centimeter times centimeter, giving us the proper unit of centimeters squared. We have a parallelogram now, which has the same idea as just simply a rectangle, just slightly tilted. They cover the same amount of area, and so we're going to use the formulaic idea again, that area equals length times width. Or you could use base times height, and the length being 3.1 from this value here, and 2.1. So equals 3.1 times 2.1. And I'll just throw that in the calculator here. I'll just clear off the screen so it's less jumbled. 2.1 times 3.1. 6.51. So we're going to use the decimal precision that we have, 6.51. Again, we check our units. We have a meter times a meter, giving us, because we have the units times each other, we have a unit squared. So 6.51 meters squared. This one's going to be a little trickier. We have example 2. Finding the area of the following figure. In fact, to find the area, we need to subdivide it into multiple parts that we can work with. There's many different ways to do this. These are the ones that I'm going to choose. And I'll just keep with the blue. Alright. One of the things that I saw is this giant triangle. So I'm just going to simply draw a line here and make it a triangle. I'll call that area... Actually, you know what? I'll leave that to the end, because it's a little bit more challenging to get its values. I see this little rectangle here, and I've got all the stuff I need to create and find the following total area. I'll call this one 1, I'll call this one 2, and I'll call this area of this triangle 3. Now, area 1 is a rectangle, so I'd say area 1 equals length times width, equaling 3.1 times 6.2. And I'll just whip that on the calculator just so we get the value. 3.1 times 6.2. It's there on your sheet, but it's good to understand how do they get these values. Equaling 19.22. We're going to leave the units. Again, it's centimeters by centimeters, so it's going to be centimeters squared. All right, area 2, I see it. We have its rectangle. We have a length here of 13.4. There's the length. And the height or the width happens to be 6.8. So I'll just work that right below here. Area 2 equals length times width. And that is going to be 13.4 times 6.8. And on the calculator, I'll bring it over here just in case you don't believe me. 13.4 times 6.8, 91.12. And of course, we're still in centimeters squared. We're going to keep that available. Now, the little difficult part here. This is our triangle. We can see that the height of the triangle is all along here, which matches up a 12.6. Now, the base is made up of two parts, namely this one here of 3.1 and this part here of 6.8. If we were to total those two dimensions up, 9 and 9. So the base of this triangle is 9.9. So the area of the third shape is base times height divided by 2. So we got 9.9 times 12.6. I'd hit that in the calculator, and then I'll take that number, divide by 2, giving us a value. Okay, let's pull that up here now. So we got 9.9. Whoops. 9.9 times 12.6. Then divide by 2. 62.37. 62.37. And again, it's centimeters squared. So the last thing we're going to do is centimeters squared. We're going to take each of these three areas and we're going to add them all up. So the total area is area 1 plus area 2 plus area 3. Alright, so these numbers that we have totaled, each one separately, I'm just going to clear the screen and I'm going to add the numbers up. 19.22 plus 91.12 plus 62.37. And our total area of this shape is 172.71, and the units are all centimeters squared. What's important to note is that we leave all the precision, all the decimals until the very end, and that's when we round at that point if the question says to round to the nearest tenth or to the nearest hundredth. Okay, oops. Alright, in example 3, we're asked to name the type of shapes because we're now working with third dimensions. Okay, now you can see that we name prisms by the shape of their base. The shape of the base can also be established from the top as well. So I look at this thing, I see, oh, there's the shape that the base would be sitting on. And I don't know if it's all the same side, so minimally I could say it kind of looks like a rectangular. Now, I'm going to have to stop. I wonder which direction, when going across the plane, is it going straight up or not? If it's going straight up, we would then indicate that it's called a right prism. Which we're going to see there's other ones that don't have to be straight up and down. Because in real life, they're not always straight up and down. So we'd say this is a rectangular right prism. Going over to B, I would see that this is the base. And I can see, I'm going to assume they're all the same side lengths because of the drawing. And I can see there's 6 sides on the base. 6-sided figures, hexagonal, I'm going to assume that the base is also sitting there flat, not drawn perfectly. Ooh, that's kind of ugly. And that the fact that it goes straight up and down from the base, and so we call that a right prism. And see, notice over there, that one's not necessarily straight up and down. So for this one, C, we can see that the base that would be here sitting on, that needs to be stacked going all the way that way, we have a triangular. Now I'm going to assume that the angle formed from the base is straight perpendicular, or rather perpendicular from that base, so we call that a right prism. Now here's where we get some funky shapes. Now we can also assume it has a nice little base that's sitting on there. Have you ever seen one of these types of objects created? Sometimes those in construction, you've made your sawhorses this way. You've deliberately cut it so you have a bit of an angle. Okay, so I'm going to assume for a second that that could be a possible square. If it's not all the same sides, we could at least call it a rectangular. Okay, here's the base as well. Rectangular, and it's a prism. But because of this weird slant, that it's not going up at 90 degrees, we call that oblique. Alright. Okay, example 4. If this right pentagonal, so we have a pentagon here, there's the base, were made from one piece of cardboard, what would the piece of cardboard look like? So now we're practicing getting what's called the net. Nets are extremely useful for when you need to construct 3D out of 2D. I know this is not the best, but it's simply a way to look at how to create this thing. Now I'm going to assume that this is the base right here, and we also have correspondingly, assumedly, another full-sided figure on the backside. Now because it's a pentagon, we can have a connection of 5 sides on all these rectangles that are sitting all around. Alright, so there's where all these side lengths, conveniently they're all 10 around because of the way it's set up for 10, 10, 10. So it's a regular pentagon, so 10, 10, 10. They all seem to be 30 centimeters along there. And now I can put my little house, or rather my pentagon shape that's supposed to look like, whoops, pen. And then I can put my front or top on there, even though it's not perfect. I could put it right in the same spot, or they could put it on any one of the places below. Typically, you line it up on the same spot. Whoops. And say there's 10, 10, that's already measured, 10, and 10. This is what it could look like. Moving along to example 5. Here we have the notion that we're going to need, possibly, to consider drawing a net diagram. In grade 9 you did this, where you've taken a third-dimensional figure and draw out the net. That's typically the procedure when finding surface area. You're going to want to draw the net diagram, if you can't necessarily see everything. Now, I'm going to add a component where we're going to assume that there is in fact a third dimension, and that we can see different sides: top, bottom, back, front, left, right. Okay, so a net diagram could very well look pretty much like this, where you've got, they typically form crosses, typically. So you got at least 4 different shapes, and you can have your front and back like that, and like that. That's one way. I'm just going to visualize the fact that I've got this space here and one behind it. Okay? Now, I see that the first front area is a rectangular shape, so the area of 1, and it's length times width. And I'm going to assume there's one at the back, so I'm going to double that up. Alright? And that length happens to be 4.6 meters times the width of this rectangle happens to be the 3.8. using the calculator, bringing that in here. Okay, clear everything off there. So 4.6 times 3.8 at 17.48. Again, we're going to leave all the precision on the calculator until the very end. That's when you round. Okay, 17.48. I'm going to write that on there now. 17.48. And because it's meters by meters, it's meters squared. Area 2. I'm about to change colors so you can see what we're doing here. Can I erase that stuff? Yeah, I'm going to erase that now. Alright. Now, I'm going to change my pen, change my ink color, so we can see what I'm going to talk about. I'll go to a nice ugly green. Now, I see that I got a side here, and I have a corresponding side here. The shape of which is a rectangle, so it's going to be length times width. And because I have two identical sides, times it by 2. Whoops, I forgot to times that one by 2. I'll have to double that up after. Okay, so this one has a length of 1.9 and a height or width of 3.8. And then I'll have to multiply that one by 2. So I'm going to keep those there. On my calculator, I've kept the other one already, so I'll just go times 2 for the previous one, 34.96. I'll write that in blue now, just because I can. 34.96 on the blue, 34.96. This one back to the green is going to be, I'll use the calculator again. I guess I could show you it in the process. 1.9 times 3.8 times 2. So 14.44. 14.44 meters squared. Now, I'm going to erase yet again this part and that part. And we're going to add the fact that we have a top and bottom. I'll do it in bright red. Alright, so we got this shape and this shape to correspond that are congruent with each other. So area 3, again, it's length times width. And because we see a top and a bottom, we times it by 2. The length this time is 4.6. The width of that rectangle is 1.9. And we're going to double that up times 2. 4.6 times 1.9 times 2, top and bottom, 17.48. 17.48. And because these are areas of rectangles, meters squared. So there's 1, 2, 3. Now for the total surface area, got to add all those 3 up. And so I'm going to do that on the calculator. I'll pull it all the way over here now. Clear. We use all the precision. 34.96 plus 14.44 plus 17.48. And in the end, this has a surface area of 66.88. And the units, because we're just adding these things up, are meters squared. Move this off to example 6. Now we have way more challenging stuff. Okay. Pen, ink color. Let's get rid of the red here and go back to blue. So we're going to try to find the surface area of this figure. There's many different ways you can cut it up and see all the different sides. One thing I would probably do is cut this thing here. And I need to make sure I get all the dimensions. Now because this length totally was 78, I need this length part right here. So I got to take away from 45, which 78 take away 45 is going to be just 33 centimeters here. Okay, and correspondingly that's 45, and the height of this thing is 30, and we have 30 there. And now this thing, we're going to need this. We've got the 45 here, we have 27 there, we got the dimensions here. One thing we're going to need, I can see, is we're going to need the height of this one, which totally it's 55. 55. But we've all got 30 up to here, so 55 from 30 is 25 this direction. And we have that as 27. We have this as 33, so we've got all the possible things. Now, this is the hard part. We got to imagine there's corresponding components on the back. Alright, so how many sides do I see? I see a very big base. Area 1, if you can see that, I'm just going to go, there's a big base. Area 1 is length times width. It's a rectangle. And it was 78 by 27. If you can hear that in the background, we could only apologize. But can't really do much about it right now from where we're at. So 2106 is the bottom space. And the units are centimeters by centimeters, so centimeters squared. I'm going to grab the eraser, grab off what I just drawing here, click. Alright, and I'll get that off there. In color blue. And we're back to writing here. Alright, we also have this little shape here, so I'm going to do this one. I'll just change the colors as you can see it as I go. So the green one, I'll just do this little one up here. It's a rectangle again, area 2. Now we got that one covered. Is going to be length times width, which is going to be 27 by 30 centimeters. And I'll just run it on the calculator on the side, 27 by 30. Which is 810. Whoops, 810. And again, it's centimeters squared. Okay, now this top piece here, we have 45. I'll just take the eraser now. Whoops. Eraser here. Bam. So now I'm going to do the next one, which I've got is, let's just grab purple. Yay. This one now is the next color. We can see, if you can visualize that, it's 45 by the depth of 27. So area 3 against rectangle. Length times width, 45 times 27. And if I was able to find my mouse again, 45 times 27. 1215. And centimeters squared. So we got this. Now we gotta get this one here. We figured out it's 25 tall by 27 deep. So I'll just go area 4. Again, I'm talking about this space here. Length times width. 25 high times 27 deep. And that's 675. Alright, now we're going to the top. Let's go pretty little yellow here. Okay, so the size, oh, you won't be able to see it on the screen, so I better just change the color of the pointer here. At least you can see the pointer color. I'll just put that to a lovely little black. Area 5, which is the yellow, and it's a rectangle, length times width, and we've got it, the fact we figured out that this length here is 33, and it's still 27 deep. $891. And area 6, which is now this part right here, we're almost done. Rectangle again, length times width. There's a lot of rectangles on here. The length is 55, and of course it's still 27 deep, so it's times 27. $14.85. Okay, we're almost done. We have a few more things to tackle. I'm going to get rid of this, this, and that scribble there. Alright, so now what we're going to do is we're going to do the front and the back, because we've done everything around all the sides. We've got the bottom. Okay, now we've got to assume that I'm going to do this area space right here, and there's an equivocal one right behind. So area 7, so this time we're going to double this one up. Oops, 7 is going to be 33, so it's a length times width, but we're going to also double it up because there's one in the front and one in the back. So we have length of 33 and the width of 55. Doesn't matter which order, or 55 times 33. And we're going to double that up because there's one in the front and one in the back. $36.30. Now, the last one to do. Erase this thing so you can see what I'm talking about. And then in color, not highlighter. I'll just do a little orangey color here now. So now the oops. I don't want to highlight, I want a pen. The last bit to do is this rectangle, but there's also one behind it, identical to it. Now it happens to be 45 by 30, so we will do that last one. That area 8, there's a rectangle, length times width times 2, because there's one front and back. It's a 45 by 30, and there's front and back. So we have times 2. So on the calculator, 45 times 30 times 2, 2,700. And all that so that we can add up all these numbers on this section here to find the total surface area. So we had to add up all our centimeters squared for all those rectangles, and I'll just do it in the calculator over here. Now I'll clear everything off, and I'll just type them all out. 2106, whoops, and so you gotta be very careful how you type each one of these out. Plus 810, plus 1215, plus 675, plus 891, 1485, plus 3630, plus 2700. Bam. 13,512. And the unit still stays the same as centimeters squared. Whew. Lots of work just for these little questions of surface area. All right. And I believe this is the last example of the lesson. In fact, it is. Kareem has been hired to paint the walls and ceiling of a living room. It's 22 feet long, 13 feet wide, and 8.5 feet high. So basically, we're going to assume this is one giant prism. 22.5 feet long. It's 13 feet wide. And then height-wise, it's not very great, but whatever, 8.5 feet. Okay, so he's got to paint everything except the bottom. Obviously, he's not painting the floor, as what you're going to assume. So what we're going to have is we're going to have to calculate all the sides to total up first. Okay, so we're going to have the following sections. I'll do this one first, this wall, and this wall. Area 1 is length times width times 2, which is going to be 13.5 times 8.5 high. And of course, this is going to be feet times feet, so we'll have square feet, and we often indicate that with SQFT. Or you can have FT squared. Your choice. Okay, 13.5 times 8.5. times that by 2. We're going to have 229.5. Again, you want to keep all the decimals until the very end. Oops. Now, get rid of this. Now this guy also has to paint the front and the back. So area 2 is equal to, okay, I'm seeing that the front has a length of 22.5 and a height of 8.5. So we have 22.5 times 8.5 times 2. $382.5. And we'll use that SQFT just because. And then the last part here, he has to paint the ceiling. Now he's not going to paint the floor, so we're not going to have the double or the times 2 this time. All we have to do is identify that we're going to just do the ceiling. I'll do that back to blue. So the ceiling is this rectangle here, which is 22.5 by 13.5. Area 3 equals 22.5 times 13.5, because it's doing just the ceiling there. 22.5 times 13.5, and that'll be 303.75 square feet. We're going to add all up of these 3 to find the area he has to paint, but we're not quite done, so I'll just add those totals up. Just in case to bring up the calculator, we should use all the precision again. 229.5. Whoops. 229.5 plus 382.5 plus 303.75. And thus, we have 915.75 square feet. Now that assumes that everything is all walls. However, that would not be a very useful room because there's no doors or no windows to get to. So now we have to do is take off and subtract the fact that we have doors and windows. Alright, so now we're going to have to calculate each one of those separately. And mouse pointer here, I'll just do a different color. I'll just do black. Alright. I hope that worked out. So we have, there's one window that's 10.5 feet by 6 feet. That's a giant window. Okay. Area. Window. Huge. Okay. 10.5 by 6. Massive. I don't even think you can even build one of those in such a small space. But anyways, 10.5 times 6. 63 square feet of window. Now we have 2 more little windows. So we have area of windows as well. Is going to be a length times width, which is going to be 3.5 by 2.5. And because there's 2 of them, double them up. $17.5 square feet. And then 2 doors. So again, we're going to have to figure out the area of the doors, and we'll double that because there's 2 of them that are 2.5 8-foot high doors. Wow. That's a pretty tall door. Very unusual height of a door, by the way. Not exactly a code door. Okay, 2.5. That's natural. That's about a 30. A 2.6 door is what that is. 2.5 times 8. And because there's 2 doors, we double that up. Bam. And we'll calculate that out. Just in case. 2.5 times 8 times 2. Miraculously, it's 40 square feet of door. Now, we're going to total up these subtracting areas. So we got 63 plus 17.5 plus 40. That gives us a 120.5 square feet to take away from the previous total here. So we're going to take that away from the other one. So we have our 915, and we're going to subtract our 120.5 to figure out what he's going to get paid for painting. So I'll just clear it off and go 915.75, take away 120.5, and this is what he's going to get paid for the total surface area of his paint. So, well, 795.25 square feet. All right, so we're going to keep that in the calculator for the next part. So 1 gallon of paint covers 255 square feet. How many gallons will he have to buy? All right, so one people often forget is we need to round up in the end. So what we're going to do is we're establish that we have, whoops, it's on pointer, not mouse, pen. Okay, this is a ratio to work with. Okay, so it's telling us that we have 1 gallon is compared to 255 square feet. We're going to figure out how to get the number of gallons we need. We don't know, so we have gallons compared here. We have square feet. We have to use this number here, 795.25 square feet. Remember, we want to figure out how to go from here to here. I don't know in my head how to do that, but I know if I take the bigger number divided by the smaller number, which conveniently is in my calculator, divide by 255, says that if I times this by 3.11 and all the decimals, I can get my answer correctly. So 1 gallon times 3.11. All right. Now here's the deal. You can't get 0.1 of a gallon, so the correct answer is still 3.11 gallons. However, you need more than 3, so you have to say we need 4 gallons of paint. You need to round in practical circumstances. Okay, 4 gallons of paint, which is going to lead us to the next question. Oh, paint costs $55.40 per gallon. I can get rid of this, and we'll use the previous answer from the other one. Okay. Now here's where it gets a little more tricky. A paint costs $55.40 per gallon, so we got 1 gallon is $55.40. Okay, we're going to need 4. That was in the previous question. Okay. So 1 gallon times 4 to get there, times 4. So in our calculator, times 4. This is stage 1, 55.40 if you want to put the 0 if you can, times that by 4. Okay, so it's going to cost this individual $221.60 without any taxes, assumingly, for just paint. Now he wants to make a profit. Profit means add. So he's going to add $225 on top of his costs. So all we have to do is add that with the calculator. Plus 225. Bam. All right, so this individual painter is only going to charge $446.60 for painting that one room. That would be an incredible deal these days. Oh, the end.